Good evening, everyone. Welcome to Professional Education Services.
So, how are you guys doing today? I hope you are all excited for what next we are going to learn in 3D printing. So, yesterday was a demand for a clip to show how the 3D printing really works, but actually it was scheduled for today. And how you work on them. So, here is a clip. Let me show you. Everyone should go to a
be printed to be someone's ear.
Oh my goodness. The project is entitled 3D Printing The premise is simple. Send a scanned image of a body part to the printer, and the machine starts building. Ears, noses, fingers. Dr. Atala's goal is to transplant the parts directly into patients.
So we're actually testing a lot of these structures right now as well. The way it works is the cells are able to...
Just start the video, please.
They start making the tissue, and as that starts to happen, this pathway goes away.
Yeah, there is an echo resound from the. So please see your phone is muted in the both volume and mic.
Okay.
Yeah, then you can start the video.
If the problem is coming in, that's tell me.
Yeah, start from starting. It will be good for us.
With what's called bio-ink, a mixture of biodegradable gel and actual human cells.
One of the big advantages of these technologies is that you are using the patient's own cells. And by doing so, really you avoid the major problem of rejection.
Dr. Atala has specialized in regenerative medicine since 1990. But it wasn't until this TED Talk 2 years ago that the promise of building body parts caught fire.
90% of the patients on the transplant list are actually waiting for a kidney. You can actually see the printer back here, and that's been printing this kidney structure that you see here. Here it is. You can actually see that kidney as it was printed earlier today.
While implanting kidneys like this is still at least a decade away, it holds the potential to revolutionize organ transplants.
Well, up until just recently, the way that we made these tissues was to actually create them by hand, one by one. When you start thinking about getting these technologies to many patients and creating thousands of these organs at the same time, you need to automate the process. And that's where bioprinting comes in.
Meaning you can make thousands of kidneys.
You can make thousands of organs. You just pick the organ you want to make, and then you allow the printer to do them over and over again.
Is this a finger?
This is actually a finger.
Right now, Dr. Atala's bioprinting is in the preclinical phase. Simpler organs will be the first to reach patients, starting with skin.
If this were in fact a wound, it would be dropping real skin cells over the wounded area.
The skin printing project is being funded by the U.S. military with the hope of treating injured soldiers in as little as 5 years. But while Dr. Atala's work is cutting edge, 3D printing isn't new. The technology has been around since the mid-'80s, mainly used for prototyping in industrial settings. Professor Hod Lipson from Cornell University says that's changing.
It has reached a level of technological maturity that it is used beyond prototyping to actually make functional parts that are used in reality, and the aerospace industry is a good example.
Some commercial planes are now outfitted with air ducts that are 3D printed, with smoother, lighter, and cheaper than the traditional method. Hollywood is using 3D printing to make costumes, like parts of a suit in Iron Man 2. And a professor in California plans to 3D print a house. In every case, a digital blueprint is either sketched or scanned and then sent to a 3D printer. The printing itself can be done by extruding a liquid, usually plastic, drop by drop, or by using a laser to fuse resins and metals.
What we have here is a sample of a titanium nose implant.
Todd, who calls himself a 3D printing addict, has just co-authored a book on the subject that will be released next week. The one thing he's betting will spur demand for the technology may surprise you.
I think it will be food. I think food printing is to 3D printing what gaming was to computers.
Already, students at his lab have printed chocolate, peanut butter, even cakes. Beyond food, there are a few disciplines hot things 3D printing won't touch. Printing an iPod, he says, isn't that far off.
If you think about the evolution of humans, we like to distinguish ourselves from other animals by the ability to make tools. And 3D printers are perhaps the ultimate tool.
But what happens to laws and regulations? You have a tool to print anything.
Next on 16 by 9, shooting off 11 rounds on a gun with a printed port.
What is a computer in the 11?
From guitars to race cars, even a model of your unborn child, people who embrace 3D printing are finding new uses for the emerging technology. Once used at the industrial level only, 3D printing has gone mainstream. Today in Manhattan, you can wander into a 3D printing store, the only of its kind, and take home your own printer for $2,200. Reed Pettis is the co-founder of MakerBot.
One of the reasons we opened a retail store is because 3D printing is still science fiction to a lot of people. The idea that you can have a machine and send it a digital design, a 3D model that's virtual, and it'll turn into something real, a physical model, it blows people's minds.
From tools and toys to models and jewelry, MakerBot's printer allows anyone to design and create.
We put the design in here with SD card. We pressed the big red M, did it jump to life, it heated up, and now it's drawing in faster.
To some, the printing is still rudimentary, nothing more than a novelty item. Reed sees it as a natural evolution.
Back in 2008, you could download movies, you could download books, you could download music, but you couldn't download this.
MakerBot's printer only works with plastic. It can only print items smaller than a shoebox. Still, more than 15,000 have been sold.
Our biggest customers are NASA, GE, and 7 out of the top 10 architecture firms in the U.S.
The digital blueprints for items are found on a website created by BRIMS' team called Thingiverse.
We've got a kitchen cabinet door handle. This is a fan duct for your air conditioning.
Over 30,000 items that can be downloaded for free.
An iPhone case. And this is a fun one. This is somebody needed carpet pin locks for their Toyota RAV4.
It's been dubbed Walmart in your home.
So we're all used to shopping. And when we want something, we shop. We think, okay, where am I going to go buy? Instead of thinking, can I make that instead?
But when you can make anything, there are seemingly no boundaries. Which is exactly the point for Cody Wilson.
We want to build the global web. The first in the world, Yeah, but the important part isn't to be the first, but to actually do it, to just have one.
Cody, a law student in Austin, Texas, is spearheading a group that's trying to create the Wiki Weapon, a digital design for a gun that anyone can download and build using a 3D printer.
You have said that what you're setting out to do will create a weapon at every computer.
Yeah, and the way of thinking that, where there's a computer that could be a weapon, or whether there's a 3D printer.
I don't think most people want a weapon at all.
I think that's fine. I don't think you should be armed, right? But I think you should have the choice to be.
While making your own gun in the U.S. isn't illegal, distributing the blueprints to others falls into a very gray territory. That's where Cody is running into a number of roadblocks. So in the meantime, he's printing gun parts to avoid breaking any law.
What's coming out is a lower receiver of an AR-15.
The lower receiver is the only regulated part of an AR-15 semi-automatic rifle, crucial to making the weapon work.
As soon as this is clean, this will be illegal.
At the shooting range, the plastic part fires 11 rounds.
That's good, considering you couldn't even get the pin in. So 11 is 11. Back to the drawing board.
People will know the name AR-15 today because it was infamously used in the Newtown, Connecticut mass shootings.
That's true.
And you're providing people a digital blueprint to replicate a regulated part of that gun.
That's right. Yeah.
That will upset a whole lot of people.
Sure, but many people are already aware of what this gun is. This gun has a proud, strong reputation coming out of Vietnam. And the civilian version of it.
Who's the military uses.
That's right.
It's a people killer.
That's right. That's what a gun is. It's essence. I mean, let's not talk about turkey shooting and hard hunting stuff. I mean, what is a gun? A gun is a combat weapon.
And you want to get people to file to go with.
That's right. Yeah.
Although Cody says he's not willing to go to jail over this, if American laws prevent him from moving forward, he may look for another country whose laws allow it.
We've met people who are using this technology to print heart valves, ears, nose, skin. I'm sure there are people out there who could say, why do you have to print this gun when there are so many positive uses for this technology?
To us, it's not, we're not makers thinking that's the best thing we can make. It's a political project. How do you achieve the results as defined?
So while 3D printing grows in a no man's land, a few rules or regulations, Professor Han Gibson is weighing the implications.
It's also important to anticipate the consequences of this technology for better and for worse.
My goal, anyways, is to say, there isn't anything we're going to be able to do about this welcome to you in the future.
And that is it.
So now everyone knows how the 3D printer works, like in FDM, how the FDM printer, how SLA printer and SLS printer work. So going back to the course, we'll start our presentation for the today's session. So this course has been conducted by Professional Education Services, and I'm the tutor Anoop Kumar, founder and CEO of Experiment Karo Kuch Naya Banao based Delhi form. So before moving to print 3D or started using a printer, in printing we should remember some things that will help you out throughout your journey, how you gonna work on a 3D printer. So first of all, I'll start discussing it with like make 3D printing as your hobby and take it as a fun. Don't discard it because you are having some failing prints. There is a juggler man over there before starting juggling or giving a wonderful performance like this. He might have broken so many of plates. So so many hurdles will come in front in your path while when you start printing. Might be your bed won't stick. There is a part failure in between. The nozzle will choke around, and many other problems will definitely come. But you have to take it as a hobby, and it's a day by day process, and you will gain some experience out of it. So the second thing is that sizing matters. That which software you are using, whether you are using an open source software like Cura and Tinkercad, or you're using premium softwares like just like 3D Simply, Simplify 3D or NetWeb or the powered by Autodesk. Both NetWeb and Tinkercad is powered by Autodesk, but one Tinkercad is free and open source. On the other hand, the Autodesk is giving a premium subscription of 999 USD per year subscription. And and the second highest paid software in the list is Simplify 3D. That will cost you around $200. Coming to the print settings part, in slicing will take as we are talking about the slicing software. Here, print settings always matters, and different print profiles at what we are working at, the speed of the nozzle head, and support. You should know how to give support to a structure. There are automatic supports available that we will discuss in next few slides, and how the tube works, and bed temperature, nozzle temperature, etc. As we discussed earlier, that print profile always matters for the print quality. Here is a print profile for different and materials like ABS, HIPS, nylon, PE, PLA, PETG, and what kind of a printer we are using depends. So that's a inbuilt database already built in your slicing software. You don't have to worry about that. But if we need a customized profile, then on the right hand side we can see a custom button over there. From there we can create our new profile, and the inbuilt profile which we are seeing, that extra fine, low quality, rough quality, coarse quality, and extra coarse. It's a auto inbuilt profile which already available in a slicer like Cura. As for our course, we work on Cura. I am using quite two softwares with me, the Cura and Simplify 3D. But I will show you the glimpse of Simplify 3D and Simplify 3D. But our course will work on a Cura. Next thing comes. One person asked me yesterday that whether we can achieve a good quality print or not. Then I must say that there are few little things that we have to take care of. Just one is like ironing. After completion of the print, this there will if we activate this ironing command in our slicing software, then that hot end will be moving on the last layer without burning any material. So that we can get a smooth finish of the topmost layer. Like we'll be getting a print quality on the bed side. Yesterday I already told you that the print which type of material we are using is also matters for that for the different application. Here we are having a PLA of hash box which works on around 180 degrees Celsius to 210 degrees Celsius. It is used for making models like architecture model, different prototypes used in day-to-day life, like a fan design or a bottle design, can design. Like I printed a mask using PLA because it's a totally biodegradable product. Because prototypes are used to work on it. They might fail, they might fail. So it will create a waste for our environment. So PLA has been used for first testing of prototypes. Then we are having a film TPU flexible material that usually works starting with 200 degrees Celsius to 220 degrees Celsius. So most of the time people to avoid any stringing, oozing, maximum oozing, so we used to work on a temperature of 210 degrees Celsius for most of the TPU printer, because this material gives having a flexibility. This like we can print shoes, rubber crocs, different design we can, even though we can make a phone case with this material. Third one is solid space material, having a named ABS, which usually works on elevated temperature like 240 degrees Celsius. And it is always mandatory to use ABS in a closed enclosure, such because it's, lots of fumes will come out of it, and it can't sustain change in temperature. If we'll print ABS in open environment, then there might be a possibility, or definitely, that print will starting warping from the bed, and it will come out while printing, and definitely there will be a failure in ABS print if you use it in open environment. And we have to maintain its bed temperature at 90 degrees Celsius compared to PLA, which works on 60 degrees Celsius, and TPU, which works on 65 degrees Celsius. ABS required the hot temperature of hot end at 240 degrees Celsius and bed temperature 90 degrees Celsius. The second most useful things to understand how should we give support. Like there is a Dr. Dooms is here. We are having a model of Dr. Dooms, but as we can say from the base, there is a platform on which Dr. Dooms is standing, and his hand is in air. So if we want give this support, if you want give support to this hand, then how we could print in air? So we can provide a manual support to a model, or it could be automatically generated by a printing software. When we give manual support, when usually people work support with 15%, but sometimes people works on to save the material and to get a quality print, because more the support will be, it will stick to the print and it will create uneven surface and smoothness will be gone. So we try to work on less and less support, but here we can't. If we can't give the support, then this print will definitely fail, because we can't make this hand in air. But in the case of SLA, there the liquid resin will provide the support, and in SLS the powder will provide the support. That's a different thing. But we have to first start doing with FDM printers. So understanding support for printing on a FDM printer is must. Coming back, going next to different types of adhesion. this red lines you are seeing, that's the mean model, and the blue lines you are seeing is support or BRIMS success. If we define the BRIMS skirt and RAFT, there is a minor difference between BRIMS skirt and RAFT. Otherwise, it is all same. First, picture A contains three lines out on the outer periphery of the model. Usually, it is called a skirt, and it is called skirt. Usually, we give command skirt starts from set distance of 5 to 15 mm. Just to know where our or print model will lie. First of all, when the printer will start, it will make a skirt, and you'll get to know whether our material is sticking to our bed or not. It will give an indication to you whether our material will stick to bed or not. Second indication it will give that when you will spray adhesive on the surface, that you should spray inside the skirt area, because outside of the skirt there will be a no printing model. So and the difference between skirt, brim and raft is that brim is having more lines than skirt. Skirt is having 2 or maximum 3 lines, but in case of brim, there are approximately 15 to 20 lines over there. That's because when our print is quite small, but if we are not using any adhesive or a spray, then this brim will provide support and make a model fixed to bed, such that while printing or over, model won't come out of bed and cause to print failure. But in case of raft, when we create a raft, then just because our bed is not uneven. Sometimes when the bed is not uneven, then we must provide raft just to level everything. There will be in raft, it will cover whole area around the model, and model will be placed on raft only. Like we can see here is the big skirt thing, like a structure. When the printer starts printing, first it will create a outer periphery of the print, like 2 gears are there. In command of this is a picture of skirt. There is outer periphery made by printer. But in case of raft, see here, totally the draft is made totally on the printer, and upon which all models are printed, and they, to get a good surface finish, as when printing on a rough surface. So, and this raft is easily detachable. There won't be any structures or patterns or the bottom portion will be smooth as compared to printing on a porous or rough bed. So as I was talking about sticking of a print for that print, that model, the print should not fail. The model should be stick to bed. Sometimes what happens, I'm talking about PLA, while printing, when printing time is more than 10 hours, and sometimes because of abnormal condition, that print start warping up from the bed, because it is not getting a adhesive or a strong hold from the bed, because we are using a plain bed or a smooth bed. So as the surface roughness is low, so it won't stick to the print model print, usually called model print, because we are printing something. So whenever I say print, then we should understand that model what we are printing is that. Okay, so here when we spray on a bed with this hairspray, usually we use any hairspray what we use to put in our hairs and make spike like structure of a hair, or some if you want to set like we use in a set wet gel. So to set a print, we need a hairspray to be sprayed on bed to stick the print. I must say that I'm sorry I don't have a pic for that, but I must say we should print always on a glass surface, just because there are extra surfaces made available to you by the company who is providing the printer, but it is quite porous in nature. And as we know, if the print bed is porous, then we will not get a fine quality on the bed surface, like on the lower surface of the print. So I must always suggest you that we should use a glass base. The glass is not the ultimate base print used for printing. There are many other the bases are available, like metallic bases from that stick to bed, that stick to the aluminum plate of the printer. Then if it can be easily removable, then we will just twist that plate, which is magnetic tape, and the print will easily fall out of the bed. This is the most important thing that we must do for our first layer, as we first layer squish. This squish, usually when we see this is too high, then the gap between bed, this is the the blue strip you are seeing on this in this image is bed, and the the red thing is our filament, what we are purging on bed to make our print. If our print is if our filament which is purging out of extruder and the shape is like around circular, then there is a little surface available, only little surface area available to get stick. But if we but on the right hand side, if you see two squished, then there might be that hot end and bed is quite near to each other, and the material we are purging from the extruder is not coming out because there is no space to material to come out. So we should always have an optimum distance between our nozzle and bed, hot end nozzle and bed, and this is just right to get print stick to your bed. So then the last thing I will tell you that, as we know, 3D printing is not like there will be hurdles in 3D printing, and to resolve those printing, we always need help from each other who's having experience, or you will be getting experience. Then you can also share your experience with others to resolve other issues. So it's always to take help from other. It is always mandatory to take help from other where you get stuck in between. Then you can take the help of any of your friends. So there are many communities around the globe about 3D printing, but here as the ProCAD Academy is providing this session. So those people who is joining through, only those students who is joining through this Pro Academy are getting a chance to join our community, having having a link of Facebook, Instagram, and with what we say Telegram @AI3DP or India 3D printing. This is a community only for those students who are on this platform doing this course with us. So for today, I'll show you one more thing.
Additive manufacturing, also commonly known as 3D printing, is a process that allows you to create physical three-dimensional objects directly from a computer design file. One of the most exciting things about additive manufacturing is it allows you to innovate quickly. You can try designs over and over and over again and actually test out a physical printed part at the end of your design cycle. And typically you simply have one chance of making a functional part. There's a whole wide range of materials that are currently being used in 3D printing, including polymer composites, metals, ceramics, and other much more exotic materials like foams, gels, and even living tissue materials. We've 3D printed a wide variety of different objects, from large things such as houses, all the way down to functional nozzles and heat exchangers for industry, all of which were enabled by the flexibility, the speed, and the new designs that 3D printing allows. The Advanced Manufacturing Office partners with Oak Ridge and other national laboratories alongside industry to help solve some of the more fundamental science-based problems that are presented with 3D printers today. And our main goals are to improve the energy productivity of U.S. manufacturers, improve the competitiveness of U.S. manufacturers, and also provide opportunities for high-paying, high-impact jobs in technology.
Am I audible, Babu? I'll show you some softwares what we use in our 3D printer. This is the software which I use, Simplify 3D. This is the Simplify 3D version which I use. As you get professional, then you must use here. From here, we'll import a model. You can rotate it, we can scale it down. And many more things we can do. If we prepare for the print, then this thing will start generating, slicing and coding for each and everything. As we can see, this green structure, what we are seeing is support for this. And this dark green structure is our thread. If I show you how the print will start, you can see how a print is looking while extruding. You can see the movement of the extruder. How that our extruder will move on a moving to the window while we print. So now the print has been completed. And here is the next software, Cura, that will work on this software. So every person who is having laptop must install Cura for tomorrow's session, and you can download it from the website ultimakers.com. I'll share you the link for it in the chat. Download link, and everyone must should have from tomorrow onwards we will work on this software. I'm sharing a link in the chat. From there you can download your Cura software. Ultimaker is the maker of it. And if anyone is having any doubt regarding today's session and for future things, you can ask me. From tomorrow onwards, we'll start working on our Cura software to start a 3D printing course. This is yesterday and today was a basic discussion on the 3D printing, that how we should start and what things we should remember for starting a 3D print. So any doubts are there for today's session or yesterday's session? If anyone has any doubt, you can ask. From tomorrow on, we will start working on our 3D printer software. Anyone is having any doubt, please ask me for today's session or yesterday's session. From tomorrow onwards, we'll start our Cura.
Hello, good evening.
Good evening.
Am I audible to you, sir?
Yeah, tell me.
Can you once again repeat this ABS material? About ABS, we have told elevated temperature and some causes about it. Can you once again repeat?
Sure, sir. Actually, the elevated temperature usually people works on usually every material works on 200 to 210 degrees Celsius. So, as I am saying, the elevated temperature means higher temperature. So, usually ABS works on 240 degrees Celsius to 240 degrees Celsius to 250 degrees Celsius. And for even though its bed works on 90 degrees Celsius as compared to others which works on 60 degrees Celsius. So here we use elevated temperature to work on especially this ABS material. Is your doubt resolved? Get resolved or anything you want to ask?
Yeah, completed. Thank you.
What use of bulletproof? Can you tell me the chemical compound? No. Is this a question related to our course, that bulletproof glass? I don't think so that we works with a bulletproof glass material. If you want to know the chemical, the name of ABS material, I can tell you. PLA usually stands for polylactic acid, and ABS stands for acrylonone butadiene styrene. Is the name? Anyone want to ask anything? Okay, sure. Even though you can use your Instagram or Facebook to join our page, All India 3D Printing. At the rate AI3DP. You can join AI3DP on your Telegram, Facebook and Instagram to join our community, which works totally on 3D printing. Only for those people who are doing a course on Professional Academy. All India 3D Printing at the rate AI3DP. This page is available on Facebook handle, Instagram handle, and our community where we can discuss everything is on Telegram. Anyone can put up any question and anyone can get answers, but we are starting with new people, so I will be there to answer. Anyone is having any other doubts with you?
doubt, I think everyone is clear.
Okay. From tomorrow onwards, we will start our Cura class. So I have posted a link in a chat. So from there you can download your Cura Ultimaker, and those who don't have their laptop with them, it's okay for them. You can manage later on. But for the students who are having that laptops with them, they can download the Ultimaker Cura, and from tomorrow onwards, we'll see that how to do a process. Then you can have a hands-on session of 15 minutes only in the end. Okay, and if you are having any doubt, then there will be a doubt session along with that.
Yeah, okay, Anoop. Thank you. Thank you for giving your time. We will meet again. So thank you, everyone. You can start leaving. This is the end of day 2.
So, thank you.